So today I'm going to talk about two new tools in SolidWorks, patterns and configurations. So patterns are a way to kind of save you some time. It's a way to repeat certain features, okay? So you don't have to model them from scratch. So there are two kinds of patterns. One is a circular pattern and another is a linear pattern. So as you can see here, this is a linear pattern. You see that? Whereas the ribs are a circular pattern. So I'm going to show you circular patterns and linear patterns on sketches, on features, and on parts, on components. So three different ways, okay? So that's going to be the first part of this tutorial. And then after that, I'm going to talk about configurations. All right, configurations are a way to save you some time. They're switch boxes. So let me give you an example. For instance, if I look at this machine, let's say I want to show three different states. I want to show unloaded, loaded, maybe unloaded for another part number, loaded, show me the setup stage, show me the running stage, okay? With a configuration, you can bind certain things. You can turn on certain mates. You can hide or show certain objects. You can turn on and off certain colors with just a click of a button. So it's really useful to use that. Okay, it's very useful to use something like that when you just want to switch your entire model with just a click of a button. Another good example of configurations is on O-rings. Let's say you got some sort of universal O-ring like this, and you want to just switch the size of it with a click of a button. You just double click it, and it's going to instantly change size. Okay, and that's really useful. Because a lot of times when you're designing, you're not really sure what kind of O-ring to specify. I mean, there's the design charts and everything. You have the Apple Rubber and the Parker Hannifin O-ring design charts that you can double check. But sometimes you just want to switch your model instantly inside your assembly, okay? And you don't want to re-import your model, add the mates and things like that. You just want to double click this configuration, and you see how it just switches? It just switches size instantly. So this is really good for optimizing. So you can use the configurations to not only build a universal O-ring, but also a universal bolt, a universal washer, and a universal nut. Okay, some of that common hardware you use all the time in design. So when you design that universal model, you import it on your assembly and you just double click. You say, hey, I want a quarter 20 bolt. I want a quarter 28. Make it longer. And that can save you a lot of time because when you do that, you don't have to import the model from scratch, remake it, delete it, re-import from the supplier. It gets really tedious. So I'm going to show you how to create a configuration from scratch, and I'm also going to show you how to create a lot of configurations using design tables. With design tables, it's just an easy way to generate a lot of configurations really quickly. So I'm going to go over how to do that to save you some time. So let's take a look. Let's take it one step at a time. So again, you don't have to remember where this is located. I mean, it's all over here if you want to know, but again, I want you to get used to using this box. I'm going to click on circular pattern, and here's how this works. Okay, you got to pick the feature that you want to pattern, and you got to pick a center of rotation. You can either pick an axis, like you see here, or you can pick a concentric feature. Let's say you don't have an axis. Maybe you want to create one. Just go to references, pick axis, and pick a concentric feature, and here you have it. You have an axis that I just created, okay? But if you don't have an axis, just circular pattern. Just pick a concentric feature from the outside. So we're gonna just pattern this, and it's gonna be, I believe, 8 times 360 equal spacing. So that's what's nice about equal spacing. It figures out the intermittent angle as opposed to kind of mathing it out, kind of doing 360 divided by 8. You know, instead of doing that, just do equal spacing and you'll be all right. So that's really all there is to it. You just click that, click the axes, click the rotation angle, click the number of instances, and then select equal spacing, and there you have it. Now I'm going to show a linear pattern. I'm still on the feature. I'm going to show you the linear pattern version. Okay, so we're going to take this beam. We got to select certain things though. Okay, it's going to be all of that except the hole and the wrap. Except the hole and the wrap. Okay, so then we gotta pick directions. If we want to make an array, we can pick an X and Y direction. If we just want to go in one direction, we can pick one. So I'm just gonna pick the axes for the direction. Alright, it's gotta be a straight line. It can be an edge or a line or an axis. And then let's take a look. 36, 3 instances. 3 instances, 36. And we're gonna go the other direction, so I'm just gonna click this box. Alright. And that's it. Let's see what we get. Let's take a look. Okay, there you have it. That's how you do a linear pattern. Now let me show you how to do a linear and circular pattern on a sketch. So let's say I were to model a perforated mesh. Okay, perforated mesh is commonly used in the industry, okay, for design. It's used for filtering. I've spec'd that a lot of times on my machines. It's like, you know, for anywhere there's fluids, right? Fluids or tools, or for washing or for anything like that, you can tell that you'd want to filter out the liquids. So there's two ways you can design a perforated mesh. One is just to put a texture with a bunch of circles. Another way is to use a pattern. Okay, so I'm just gonna draw a circle on a sketch. Okay, spec a circle, and it doesn't really matter. It's just, oh, it's a little small. Okay, let's say we drew a circle and we want to make a pattern out of this. So it's the same idea. This time it's called linear sketch pattern. Well, let me show you circular sketch pattern. If I click the circle, alright, and I pick number of instances, see what's going on? If I click OK, alright, there's the circular pattern on a sketch. But let's say I wanted to do a linear pattern. I'm going to pick the entities to pattern, which is the circle. Then see, you got the same deal, X, Y. So the X is going to be this. And we can just pick number of instances, and then the Y is going to be that. And we can pick number of instances there. Okay, so let's see what the numbers are supposed to be. 2 and 8. Right here, 2 and 8. 2 and 8. 2 and 8. And let's just switch the direction. Yeah, it looks good. I might even put a couple more just so it covers the whole thing. It's kind of hard to get access to those properties again, so the only thing you really have are these numbers. You can change the number of instances, but sometimes it's hard to get access to that whole property because it doesn't really get saved on your design tree. So whenever I kind of mess up with my patterns, I just delete. I just box select and delete and start over, or I just modify these numbers. So that's really the only amount of reversibility you have with this tool. So I'm going to click exit, and then I'm going to just do an extrude cut just so you can see this pattern a little bit more. And I'm going to do up to surface on this. Let's see what we get. Okay, so there's our perforated mesh. Alright, so I just showed you linear and circular patterns on features and on sketches. So now I'm going to show you how to apply the patterns on a assembly. So what I have here is an assembly with just one bolt, and I'm just going to create some axes. Okay, so I'm going to insert an axis here. Okay, and then one like this. Okay, that makes sense. So I have two axes, and I'm going to use these to create a pattern. So this is on the part, it's not a feature. A feature is just like a revolve or an extrude. This is an actual imported part. So let's see, if I want to do a circular pattern, it's the same idea, right? Actually, let me add one more. Okay, let me add one for this one. Alright, so now let me do a circular pattern of this. See, there it is. And this is a very, very common function. You always have patterns of bolts like this. You just don't want to do this from scratch. And look, I mean, it saved me a lot of time. I mean, it didn't take me a long time to do this. So you can see how helpful that can be. Alright, now let's do an array. So I'm just going to pick this. I'm going to pick this. And let's see if we can add, there we are. You see? And then let me pick another direction. And then here's the other direction. So let's see what we get. There we are. So not bad, right? Not too bad. One thing I would caution is sometimes when I've used this, it tends to glitch out a little bit on updating drawings as far as configurations are concerned. So sometimes when I've had to update configurations using the pattern tool, I've noticed that it glitches out. It doesn't update properly. So just be aware of that. Sometimes you have to hit refresh. I mean, you can still get it to work, but it's going to be a little bit glitchy when you work with slightly complicated models and assemblies. You might come across problems. So there's a pro and con to using this tool set. But that concludes the patterns, okay? So you can do it on a part, on a sketch, and on a feature. So now let's move on to configurations. I've already talked about the many benefits of configurations, but another one I didn't talk about is to help consolidate your workflow. For example, if you have a product that's kind of similar to another product, okay? You don't want to just create a separate model or separate assembly for both. You want to kind of morph just one model into the changes, into its variations, into what they're called as configurations. So for example, these two products are very similar. I wouldn't do this in one model. I'm sorry, I wouldn't do this in separate models. I would do it in one model, and then I'd have a certain configuration to say, hey, turn this off, turn that off, make this bigger, make this smaller in one configuration. So that's a much cleaner way to work. So I encourage you to kind of consolidate your models into just a few files that have a lot of configurations so you can modify like what you see here. And this is not only good for the models, but also on the drawing, because on the drawing you can then change the configuration to whatever you want, and it makes it so much easier to work when you can consolidate in this fashion. So we're gonna add a configuration on our beam. So let's see if we still have our beam here. Alright, and what I'm gonna do is I'm gonna add a configuration here by hand. So it's gonna be right click, add configuration. We can call it 3 feet. I like to turn this off, suppress features, because it just gives me problems. Alright, so I've added 2 configurations, and now what I want to do is set the 1 feet to only show 1 and set the 3 feet to show 3. So what that means is on this pattern that I created, let me delete this perforated mesh that I created, because it's gonna give me problems if I leave that. Okay, so here's the pattern that I created, and so you guys select configure feature. This only happens after you have at least one configuration. So this is where you suppress it. This is where you switch the suppression. So let's see here. We said 1 feet. We should suppress the pattern. So let's see what we get when we click OK. Go back to configuration. Let's click 1 feet. You see, there's 1 feet. We double click 3. Alright, so I just showed you how to configure a suppression. Now let me show you how to configure a size. So let's say we want to add another one, big diameter. Alright, and let's say it gets a little weird, but we're gonna make this configurations primary this. Alright, let me make this 10. Sure, it says this. Okay, see what happens when we click exit. So we had to click that configurations button. Again, these buttons don't show unless you have at least one configuration. We're definitely going to get problems because when you change a dimension, everything else is dependent on it. So I just deleted those steps to clean it up a bit. But let's see what happens. Let's see what happens when we do 1 feet, 1 feet, 3 feet. So I just wanted to show you that you can connect a dimension to a configuration. You can also turn on and off mates. Alright, by that same switch box that I showed you, you can turn on and off features like I just showed you with configure features. So those switch boxes can be turned on and off any way you like in the program. So now what I want to do is show you how to create lots of configurations really quickly using design tables. So I just created a file, a brand new part. It's not an assembly, it's not a drawing, it's a part. And I'm going to generate that donut, that O-ring. I want to build a universal O-ring to show you that process. Okay? Because then you can use this knowledge to build your own universal bolts and screws and things like that. So we're going to just pick a regular 1/16 O-ring. And I'm just going to set this default to 1. Okay, so here's my sketch. I'm going to exit out. And I'm going to revolve on this axis. Okay, so this is just our basic donut. But we need to know this size. So you can go on any supplier site like McMaster, Apple Rubber, or Parker Hannifin. And these are standard dash numbers. These are universal throughout the industry. And you can get an ID, inner diameter, or an OD, outer diameter. And you can take those numbers and go in Excel. You can type in, okay, this is dash number 07, this is dash number 08, and so on. Okay, and then you can maybe type in, alright, then the first number is 1, the second number is 2, or whatever it is. Let's say that's the ID, and then that's the OD, and you just type those numbers. Okay, just type those numbers, and then maybe that's the OD. Let's pretend that it's just that. You can put it in here and then you just drag that through and now you got averages. So these are really the two numbers that matter. You can paste values here and you can there. So this is what we want. Okay, these are the numbers that we want. So let's say you did that from the catalogs and now you're ready to insert it onto your design table. So I'm just going to copy this info, and inside here we're going to first, I'm going to prime this. So there's at least 2 configurations. So I'm just going to call this one test just to prime it. And then once I have 2, I can go inside here and I'm going to set this to be activated for this configuration. It's just something you got to do to prime this. Okay, so now I'm ready to insert the data table. So it's insert tables, design table. It's going to be blank. And then it's going to ask me, well, which items do you want to insert? Just the sketch here. This is the diameter. Remember that diameter that I set as this configuration? That's the only specification that I want to insert. And then I can go in here and remember, we save these numbers. Oh, jeez. Control C, and then I can hopefully paste this. Actually, let me just use this button because sometimes it glitches out. So here I just pasted the numbers, okay, from Excel. Or I could have just typed it in here directly because this is an object that sits inside the interface. So this is actually Excel. These are Excel buttons inside my SolidWorks interface. So it's pretty much the program in SolidWorks. But anyways, once you insert that, watch what happens when I click outside. It's asking me now, do you want to insert all these configurations? And then you say, okay, yes. And watch what happens. You see that? It inserted. Let me zoom out. See, it inserted all those configurations in one shot. So that's the benefit of the design table. It's that I can insert all these configurations in one shot. Alright. So I encourage you to take advantage of this tool set. I didn't really understand configurations until maybe my third year as an engineer, and I didn't realize how much I missed out, to be honest. If I knew about it earlier, I would have saved myself a tremendous amount of work, because I used to have a separate model for all this. I used to have a separate model for the loaded state, the unloaded state. So it was incredibly inefficient. So I encourage you to practice creating a design table and creating a couple manual configurations so you understand how it can be used.